We are told that O is the center of the circle, and we are told that angle C1 is equals to x. So this is angle C1 is equals to x. We can see that in this theorem here, or in this sketch rather, they included two theorems, theorem number 4 and theorem number 5. Theorem number 4 of angles in the same segment, and theorem number 5 of cyclic quad, because here I see a cyclic quad and here I see angles in the same segment. When you see this bow tie here, most of the time is angles in the same segment. So how do we answer these questions here? Question number 1 on your right, it says name with reasons 3 other angles that are equals to x. So how many angles do we have here? How many angles are equals to x? Well, we can see that angle C1 is equals to angle A1, and the reason for that is angles in the same segment. So we can say angle C1 rather, or angle X if you want to say, is equals to angle A1. The reason for that is that they are angles in same segment. They are angles in same segment, and yeah, you can see A1 is equals to X, and yeah, let's move on to, let's look at another one. If this here is a diameter, that means this here are radii rather, this here are radii. Remember that a radius is a line from the center to any point on the circumference. So if these here are equal, that means angle, this angle here, angle E, is equals to angle A1. Remember those 3 reasons that I told you. So we can say angle E is equals to angle A1 is equals to x. The reason for that, there are 3 reasons for this. You can say angles opposite equal sides, or adjacent angles of isosceles triangles, or equal radii subtends equal angles. So I like using this here, equal, no, where am I saying equal? Angles opposite equal sides. You can use one of those 3 reasons, but I like using this one here, angles opposite equal sides. So this is angle number 2. Let's find another angle. So we say this angle is equals to x, also this is equals to x. Also let's look at in the other side. If this is a radius and this is a radius, that means these angles here are equal. So we can say, what is this angle? Angle D is equals to angle C1 is equals to x. Again, angles opposite equal sides, like this here. So we answered question number 1. We are done with this question here. So all of these angles here are equals to x. Yeah, let's move on to another question. It says here, write the following angles in terms of x. That means in our answer there must be x, and yeah, let's answer it there. So the first angle that we must do is B. How can we write B in terms of x? Remember in the beginning I told you that ABCD is a cyclic quad, so the opposite angles of a cyclic quad are supplemental. So that means that angle B is equals to 180 degrees minus x because of the opposite angles of cyclic quad. Let me see CQ. You can specify the cyclic quad. You can say ABCD of cyclic quad ABCD, so that the marker can see. So how can we write O1 in terms of x? This is O1 here. How can we write it in terms of x? This was A, so B. We know that O1, let's look at this here. O1 is the exterior angle of this triangle here. So O1 is equals to x plus x, this here. So angle O1 is equals to x plus x is equals to 2x because of the exterior angle of triangle. You can specify the triangle here. You can say this triangle here, this triangle COD if you want, or you can say this O1 here is 2 times this angle here, or is 2 times this angle here, or is 2 times this angle here, or is 2 times this angle here. So at the end of the day, O1, let me say, or angle O1 is 2x. So angle at center of the second is equals to angle is twice angle at circumference. You can finish this with there. And yeah, this is how you answer these types of questions. I believe we are done here. I will see you in the next video.